So we always refer to this as the money shot. This is the business end of the battleship, the front end of turrets 1 and 2. This is what projects power. We used to say that when a battleship arrives in a port, it provides presence, if nothing else. When you park this off of somebody's shore and then suggest that they behave a certain way, they're usually pretty eager to accommodate. So at the very top, you have 2 radars. Below that is 16-inch gunnery control. The 2 boxes on either side are electronic countermeasures. The round antenna is satellite communications. And then below that, there's the battle bridge. And the battle bridge is kind of interesting on this particular battleship. If you look at all of the older battleships, you'll see tripod masts or cage masts with a huge control room at the top. And that was so that people could get up high and look over the horizon. This battleship was built with radar in mind. And so the battle bridge is not the highest part on the ship. It's actually on the 08 level. It's 8 decks above the main deck, but it still has a battle bridge because it's a battleship, and the designers just couldn't step away from having that battle bridge. As I want to say on occasion, the Navy is 240 years of tradition unhampered by progress. So 2/3 of her main battery is here, 6 guns forward, and then there are 3 more aft. You know, it's really hard to get a perspective of size without standing next to it and actually putting your hands on it. You know, to put it in a little bit of perspective, the weight of the round that this shoots is roughly the weight of a Volkswagen Beetle. So you could pick up the compact car of your choice out of the parking lot and throw it 23 miles and land it within a 10-meter square at the target area with this. And its mechanic is just like it's just like a rifle or a pistol. It's just a giant gun. The 16-inch rounds come in a variety of flavors. One of the more interesting ones is this round. This is a practice round. This is never fired. It's used for practicing loading the weapons, and the flat end on it is because they would load a weight in the end of the barrel. They would run all the way through the loading process, and then they would raise the barrel, and that weight would slide down the barrel and hit the flat end of this round and drive the round back out of the weapon so that they could practice loading again. So the whole purpose of this round right here is just to practice loading and unloading the weapon. This round right here is called a BLMP round, a blank load and plug round. This is, the blue on here indicates inert. There's no explosive in here. This is basically filled with concrete. This is a practice round. When I was on board here, we shot almost every day that we were at sea, and this would be the kind of round that we would fire. It has no explosive in it, it has no fuse in it, it's just loaded and fired. It's a big chunk of steel and concrete that we fired at a target we called the Killer Tomato. It was a big aluminum balloon that we would throw over the side, and it gave us enough of a radar image to target. And we shot those almost every day. These bags represent the propellant. The propellant is stored in 110-pound bags. There are 6 of them in the powder train for a total of 660 pounds of propellant in a standard charge. My favorite round to talk about here is actually the W-19, also known as the Katie round. That is an actual nuclear round. It was developed, it was tested, and it was in fact stored on Iowa, although thankfully I don't believe it was ever used. The Katie round, like so many of the early nuclear rounds or nuclear weapons, had the distinction of you being inside the envelope when it contacted the target, which is a polite way of saying you'd never wanted to shoot that because you weren't going to survive any better than the enemy was. So the final round that we have on display here, this is an armor-piercing round. So this is the larger of the 2 rounds. This is a 2,700-pound round, and it is designed to penetrate the armor of an enemy battleship. And so the interesting thing about an armor-piercing round is it actually will not fuse until it passes through armor. And so one of the places on this deck or on this ship is a thing called the splinter deck. And it's a place where we have 8 inches of armor below and only 1.5 inches of armor above. And it is designed to defeat an armor-piercing round. The round would actually penetrate armor and fuse and then detonate in a space that was less critical to the ship that had both armor above and below it. What we have here, this is known as the powder train. This is what it looks like inside the barrel just prior to shooting. We have a BLMP round here that we spoke about before, the blank load and plug round. This is a practice round filled with concrete. Behind it, we have 6 dummy bags. Now, these are obviously not real propellant bags here on display. but they are representative of what would go into the weapon. The round comes up vertically, and then it lays down on a table, and a rammer pushes the bullet in first. Then it's retracted. The elevator has two sections in the car. 3 bags are rolled out, pushed up by hand. 3 more are rolled out, pushed up, and then they are rammed in to the barrel, and the breech is closed. So just before firing, this is what the powder train would look like. So the 660 pounds of powder will move this 300-pound round, allowing us to put it on target up to 23 miles away. But you move pretty fast through here. So this is a remanufactured ladder because this is where we bring our engineering tour down. The first step is still very, very long, so be careful on the first step. Watch your head as you step over this. The steel is pretty unforgiving. All right, so this is Broadway. This is home to me, right? So Broadway is the longest contiguous passageway on the ship. It runs through our entire engineering spaces. So beneath your feet is forward auxiliary machinery room. That's the first engineering space. This space is the #1 fire room, then 1 engine, 2 fire, 2 engine, 3 fire, 3 engine, 4 fire, and 4 engine, and then aft auxiliary. So this is the engineering plant. It is encased inside the armor belt because without your engineering plant, you can't move and you can't fight. Everything on here is powered by steam. There are not enough backup generators and diesel to actually fire the weapons. The diesel generators give you only enough power to restart the steam plant, which then gives you enough power to move the turrets. There's a couple reasons why this is set up the way it is. Sitting where I am, I'm on the center line of the ship. So I'm in the exact middle of the ship. And I am surrounded by the best armor that the ship has, including the engineering spaces themselves. This overhead trolley, while it was used to move equipment around for maintenance, was designed to move ammunition between turrets 1 and 2 and turret 3. So should one of those turrets become incapacitated, then you would be able to still use the ammunition in the other turret that was able to fight. Just regular workday, in the middle of the workday when you're not changing shifts or changing watch, you would still never see this empty. It would never be empty. You'd have 3 or 4 people transiting in here all the time because there was stuff that you had to do. I made fresh water in a space that is below and behind you. The water lab that tested that water is almost all the way at the end of Broadway. So you'd have to take the water samples down there. The water samples would be coming out of the boiler rooms to see whether that water is suitable to continue to use. So you'd always have people coming and going to the water lab. You'd have the messenger of the watch taking things to engineering main control. You'd have people that were coming down to damage control central, which is the space immediately behind you. That controlled all of the configuration of the ship in terms of what ducts were open and what doors are open, what we would call the material condition of the ship is. Main control was in 3 engine rooms, so you had people going back to main control to bring equipment online or get permission to bring equipment online, to tag it out for maintenance, lock it out for maintenance. So there was a constant traffic in here all the time. These doors would remain open unless we were at general quarters. Once we went to GQ, these sections of the trolley pull out and these doors would have been closed. So at general quarters, almost every door on the ship is closed because you want maximum watertight integrity, because if the bad guys punch a hole in you, you want to only flood one space. There's another incredibly steep ladder here for you. A lot of what I do does not take me down to engineering, right? And engineering is where I lived and worked the whole time that I was on board the ship. I very rarely went above the second deck. I mean, literally, and I know people think it's strange, but I very rarely saw the sun. It wasn't something that I did. I, lived on the third deck, ate on the second deck, worked on the seventh deck. There's no reason to go topside. The farther up I go on this ship, the more lost I become. People are like, oh, you served on here. What's this? I'm like, I have no idea, because it's not in engineering, right? So this is an engine room. Engine rooms ran somewhere between 110 and 115 degrees, typically, maybe 120. It was, and humid, because you're working with steam. It's interesting because this is the engine room. This is one of Iowa's 4 main engines next to me, and people don't think about it because they're looking for something that looks like a car engine. This is a steam turbine. The high pressure turbine is the little one. The low pressure turbine is the big one. Everything down here kind of feels like it's backwards from your intuition. This is the reduction gear. This doesn't produce the power. This actually takes the turbine's power and converts it into a single shaft that goes aft out of here. It's loud. It's really, really loud. You use a lot of hand signals. We would wear what's called double hearing protection. So you have the little spongies in and then the little Mickey Mouse ears over the top. And when you needed to talk to somebody, you got right up next to their hearing protection and screamed into there, and they might be able to hear you. If you're in here cold iron, which is what we would call this, and you stood watch all the time, whether you were steaming or not, cold iron, you were usually by yourself down here, and it was deathly quiet like this, just the ventilation fans running, which we don't have running now. And the phone would ring, and it would wake the dead because it's designed to be heard over the plant when it's running. But you have this high pressure turbine, this low pressure turbine, and then behind you, you have 2 ship service turbo generators. Just imagine everything being 600 pounds pressurized and 900 degree steam. Yeah. So this is the throttle board. This is the actual control of the engine. And it gives you an idea of, I mentioned the modern Navy or nuclear Navy has the same turbine. This is all digitally controlled from an air-conditioned booth, right? This is not an air-conditioned booth. It is not manually controlled or automatically controlled. When you want to go forward, you grabbed this valve and you turned it, and it would open the valve. This valve is open right now to 5.5. Right? If you wanted to go backwards, you would shut this valve and you would open this valve. And you literally put your hands on it and twisted the valves, and that's how it worked. Right above you to my left is one of the few areas that we were able to modernize. That is it's an electronic salinity sensor. So that would test to see whether we had salt water or contaminants in the steam and the water that was going to and from the turbines.
Can we just get an idea of what we're looking at? I mean, what are the most sensitive ones you have to keep an eye on?
The most critical? The clock, so you know when to change the watch. So really your main steam pressure is important to you because that tells you how much steam you're available to. Main condenser vacuum, if you lose vacuum on the main condenser, you're not drawing the steam down through the turbine. That's a bad thing. Your main steam pressure and temperatures, which are here, everything kind of works in concert, right? Pressure and temperature are correlated. They're related to each other, so you may see one change before the other one changes, but they're going to affect each other. And then water level. Your water level is super important because this is a remote water level indicator for the boiler that is feeding here. You're drawing high pressure steam into the turbine. The steam is at between 800 and 900 degrees at 600 psi. And so it's hard to wrap your head around. I mentioned on the main deck, this ship has a lot of things that seem counterintuitive, right? 800 degree steam is dry. It is steam that has no moisture content in it. Okay, so think about the fact that you have water vapor that has no moisture content in it. It takes you a minute to get your head around it. But if we had moisture content in it, if we carried over water into that, these blades are so hot and they're so fragile in the turbine that if we hit them with a drop of water, they would shatter like glass. And so you don't have an extra turbine on board. This is your lifeblood. If you cannot move, you will die. You know, read about the Bismarck. Once her rudder was jammed, you lose main engines or you lose steering, you're sitting duck. And so these are built to be very, very survivable. But they do have some areas where you could damage them. And the engines are really one of those really sensitive areas. So water level is important, temperature is important, pressure is important. So this is the top end of the boiler. This is how we make steam. In the 1940s and 1950s, we burned something called NSFO, which is the Navy Standard Fuel Oil. NSFO is one step up from crude. It's thick, it's like pudding, it's not highly refined. It had to be heated before you could run it through pipes. It was incredibly difficult to work with. In the 1980s, we burned diesel fuel marine. It's basically number 2 diesel. The only alteration that needed to be made to these boilers to do that was to change the tip in the burner, which is about a 25-cent piece. This right here is the steam drum, and I mentioned how water level is super important when I was down there on the throttle board. So inside this water drum is steam, or in steam drum rather, is steam on top and water on the bottom. And you want the level to be right in the middle. As you draw steam off to go to the engine, the water level rises. As you make more steam in the boiler, the water level lowers. It's pretty important to keep it right in the middle. If you have too much water, you'll carry over and ruin the turbines. If you have not enough water, you'll actually push steam down into the boiler and create the conditions where you could have a boiler explosion. It's rapidly expanding steam. So super critical job to keep that right in the middle. It's called the checkman's job. The thing is that you have a thing called a crow's foot. It's basically just a big crowbar. If you look at these valves, you can see how they're kind of chewed up because you put a crow's foot on it. It gives you a little bit more leverage to turn those. And your job is to, you know, when the water level goes up, you turn the valve, and it comes down, you turn it the other direction so that it's held right here at this end. So yeah, checkman's job, super critical, usually done by somebody super junior. It's like the first thing that you do. You learn how to stand check. This is the middle part of the number 7 boiler or 4 alpha boiler, right? 7 or 4 alpha, I keep saying that. Why? Because you're in the number 4 engine room. This is the alpha side. So it's referred to as both, but the big 7 here tells you it's a number 7 boiler. There are 8 boilers on board Iowa. They are M-style twin furnace boilers, which means I have one set of furnaces here. I have another set of furnaces up on that raised platform. So this set of burners right here, these, create what's called saturated steam. So this is going to come out here somewhere around 250 psi and hot but wet. And then we're going to take that steam and we're going to put it back through another set of burners. So we're going to bring that temperature up to about 850 degrees and we'll bring it up to 600 psi. Each one of these has, you're controlling fuel and air. But one of the things I always used to tell people is this is called a fire eye right here. This is the ignition port. We literally, people are like, how do you start the Iowa's engines? I'm like, with a Zippo. They're like, no, seriously. And I'm like, no, seriously, with a Zippo. So this is a torch. On the end here would be a piece of cotton, usually. And then you would dunk that in fuel and you would light it with your cigarette lighter. And then you would stuff it into the boiler in order to light the boiler. So literally the main engines on Iowa were started with a cigarette lighter. This is our ship fitter shop, but one of the coolest places over here is this right here. This workbench has this stamped into it, which are all of the sailors present in this shop during VJ Day. And then you can see 86, when the Statue of Liberty was rededicated, it was here, and then there's a decommissioning crew over here. The difference in the quality of work between the World War II sailors and my contemporaries in the 80s, almost embarrassing, almost embarrassing. Typically sheet metal and fabrication is done in here, welding. The next shop is our electrical shop, which includes a bunch of electrical rewind equipment. When we were at sea, you couldn't just, call Menards and say, send me a new motor. You had to do something. And so we could actually remanufacture every electrical motor on the ship in that shop, and in addition, deal with lighting and whatnot. So we still use the electrical shop to do electrical work. But this one is mine. So this was auxiliaries. This was where I started every day of my life for 2 years. We used to hold quarters in here. This is one of the most amazing machine shops I have ever been in. And we have a machinist who works in here who's retired. And he has gotten almost every single piece of this equipment working. We had lithographers on board. We had draftsmen on board. You could draw the plans up. You could bring it down here between here and the ship fitter shop where we had a foundry. We could cast, we could mill, we could weld, we could do sheet metal. We could literally build any port that we needed here.
When the rangefinders and everyone feels what they have their target locked in, and the plot officer or petty officer decides, okay, we're good to go. He locks the plot in with this, and this spins up and starts calculating on what it needs to know on how to hit what we're shooting at, and that plot ready light right there will come on. And when that comes on, and all those 1, 2, and 3, those are turrets 1, 2, and 3. When those are green, that means the guns are ready, right? He'll step on this little nodule here on the floor. What that does is that syncs it with this stabilizing unit. The stabilizing unit then takes and rotates the turrets and elevates the guns. That's what actually does it right there. And then once that comes up and says it's ready, then they're ready to fire. And there's 3 triggers over there. One is a salvo warning saying, sends an alarm throughout the ship saying guns are going to fire. Clear deck or hearing protection. And then there's an automatic fire, and that fires all guns, the main guns. Now, say we hit a wave really bad, or we roll, or something happens, but between the time that this is synced up and you pull the trigger on the automatic firing, nothing's going to happen. Because the stabilizer knows that the ship's not in the optimum position to fire. And it waits until the ship returns to position and then fires. There's a manual firing which will override that if you absolutely feel you have to fire.
This is my exhibit. I'm still working on it, but I designed it. I put it in largely by myself. There are 4 basic restaurants, if you will, on the ship, for lack of a better term. There's the general mess, which feeds E6 and below. It would be nice to say, oh, you've got 4 restaurants and you can choose. Well, you can't. So E6 and below is fed in the general mess. E7, E8, and E9, or chief petty officers, senior chief petty officer, master chief petty officers, are fed in the chief's mess. The officers are fed in the wardroom, and then the captain and admiral have their own private galley called the captain's mess. So 4 places that you can cook food, 4 places that you can serve food. One of them serves 8. One of them serves about 85. One of them serves about 100, and one of them serves the rest of the 1,800 people that are here. So this is the main ship's galley. There's a chow line on either side. A lot of steam-powered cook gear because we had a lot of steam on the ship. And again, looking at being fairly efficient, We would take the exhaust from the steam from the engines. People think, oh my gosh, engine exhaust. No, it's just steam. We would take that steam that had already been run through the turbines, already driven the ship forward, and then we would use it to cook with, we'd use it to heat with, we'd use it to do laundry with, we'd use it all over the ship to run auxiliary systems, and then we'd still bring it back and condense it and run it through the boiler again. It was really a very efficient system. This was called the main line, and so here in the morning, for instance, you could get eggs to order, you could get omelets, you could get hash browns, and you'd stand in line, you'd tell the cook what you wanted, he'd cook it for you and give it to you. On the other side was the speed line. It served the same thing every day. There was no variation on the speed line, but it was always available. The line moved a lot faster. So for breakfast, you'd get Navy beans, because that's 240 years of tradition unhampered by progress. That's a traditional Navy breakfast. You had Navy beans, hash browns, scrambled eggs, bacon, sausage, French toast, cold cereal. And so that every day you just run through the speed line. For lunch and dinner on the speed line, it was always hot dogs, hamburgers, what we called Frisco fries, which are like fake French fries made out of reconstituted potatoes. Not very good. For dinner, you might have steak, you might have chicken adobo, you might have spaghetti and meatballs. You know, it varied from day to day, your lunch and your dinner. Of course, I was always so important as a 17 and 18-year-old kid that I had to get back to work because I was the key that kept the ship running. So I always went through the speed line. Looking back, I'm like, you know, I question my life's choices sometimes. So.